And good evening, folks, and welcome back to the page, Astronomy by the Bay. It's Chris Kerwin here with you, and tonight I have Paul Owen with me tonight. Mike has to work tonight. Mike's in the job there, in his production job, so we have to leave Mike alone this evening. Let him do his thing so he can pay for more of his toys. So this evening what we're going to do is we're going to try to present a little bit of a talk on satellites invading astronomy and what we're a little bit afraid of coming up. I'm sure a lot of you have heard about the new Starlink group of satellites that'll be, or no, there's a number of them up there already. I guess 100 or so already are up there. And we know that there's going to be up to 12,000 more of those satellites, and then possibly another. Amazon is looking at the same option with maybe 2,000 or 3,000 satellites, and another company called One World Internet. And I'm sure there'll be more along the line when they find out if this is profitable or not. So we're really concerned about what it's going to do to true astronomy, and for those here on the planet that do exercise true astronomy, like Paul, for instance, as well as his astrophotography work that he does. So Paul's going to give us a bit of a talk, and we're going to discuss a little bit about it. We're looking for your comments too on this. So if you'd like to add in some comments, I'll be watching the live stream here on YouTube and be watching the comments as we go through. So be sure and comment if you like. And hi, Irene and Mike. Good evening, Mike.
Hey, Mike.
Hey, Mike.
The Simpsons. Private joke.
We're going to try to keep that light tonight. So we got Louis and we got Enjoy the Decline. Welcome back. Okay.
Hello.
And Sigthorn. Hey, hi all. Perfect. So I guess we're set to go. Let's get into the topic a little bit, Paul.
All right. Well, I'm going to share my screen there.
Okay.
And I think I might have shared the wrong thing, but just give me a second.
Oh, that's a nice Andromeda.
Yeah, well, that's not what we want to see right now.
Hey, Trudy.
There we go. Hey, Trudy. There. Okay. So I think we'll start with this image.
Mm-hmm.
And what this is an image of eventually what the traffic is going to look like around the Earth with these satellites that and we're not talking about Amazon or the other fellows. This is just from SpaceX and from Starlink. This is going to be their network of satellites that you can see. So so as you can see there's this eventually is going to be somewhere in and around the 12,000 satellite mark. Right now they've got about 300 satellites up there, and they were set up to do another 60 yesterday, but on one of the rockets they had a stage 2 problem on one of the rockets, so they had to delay it, and so now those other 60 are going to be going up tomorrow. And in order for them to be able to have a network up and ready this year for parts of Canada and the US, they have to have at least 360 satellites up there. So so they'll do that for sure. So that's kind of what down the road is going to look like. So it kind of reminds me of going back to the days watching the movie Blade Runner, when we never thought that we would see this kind of electronic traffic in and around us, encircling us as the human world amongst all this stuff. So yeah, I'm not against it or for it. I'm just kind of just give you the facts tonight, but it does pose a lot of issues both ways. So I guess what brings up this topic tonight, and what we're seeing a lot in the threads from a lot of the amateur astronomers and professional astronomers too, is what's happening with these few satellites that are up. So we've only got maybe not even a tenth of a percentage of what satellites are going to be there. And this is what we're starting to see already. So if you look at this image here, what you're seeing is all of those dotted lines is Starlink satellites. And this was an image, if memory's any good, this image was taken in Chile, where they're doing a lot of research. And this was in that last deep hour of darkness before it starts to get light, and that's when these things are going to appear, because they do appear in and around that time frame. And I think this was something like 40 images that they took. And as you can see, there's a lot of stuff going on with that data. So of course, their concern is, how usable is this data going to be? Can they recover some of this stuff? And the part that I guess that really strikes me a lot on this is the fact that there's that much trailing going on with only a few satellites up there. So what's it going to be like when you get the 30,000, which is really the number they're looking at
Mm.
between all the companies up and around us? What's that going to look like? So a lot of these astronomers are very concerned, especially with certain types of radio astronomy is affected greatly by these. So there's all those kind of concerns that are happening with that.
It's true. It's not just optical viewing that we're talking about. It's radio astronomy because
Yeah.
these things send out a frequency, of course, and when they're listening to objects in space, radio astronomy is all based on that. So it can really it's really concerning them as well. I think there's a new observatory, I believe, like it's going to have a 30 gigapixel camera ability
Hmm.
in one shot, 30 gigapixels. So they're really concerned about that one. It's a $2.5 billion new telescope.
Yeah, well, that's the thing. There's a lot of concern with a lot of the equipment that's built, because then software, like if you're doing just natural or I shouldn't say natural, amateur astrophotography, like a lot of us are that enjoy the hobby. There's software that'll take out satellite trails and stuff like that. But when you start getting this many of them going through some major components in your image, it's going to be a little bit of an issue, I think. But on the upside, it's only going to be anywhere between 30, I think what I read is between 30 and 45 degrees in the sky only at a certain time. So it's not all doom and gloom for sure.
Mm. Somebody was mentioning why is there not as many over the South Pole, Paul, at the moment, I guess.
Over the South Pole?
Yeah, it doesn't seem like there's when you showed that first picture there.
Oh, back here. Let me go back here now. This one?
No, back one more.
Over here?
Yeah, that one, I guess.
Okay, well, what you're looking at, if you look at that picture, and this is just purely, what I'm seeing here, is if you look at that circle, it's totally like, don't not so much what's going across,
Yeah, we're just
just
static
what's up
here, right?
above the sky. But you got to remember, all of these things are in orbit, so they're all moving. So this would be, and this is just a rendition, right? This
Yeah.
isn't, somebody didn't go out there and take a picture.
No, we're
This is
not.
just a computer generated image. So
It might have been different if we had Antarctica turned around a little bit more, so that yeah,
yeah, exactly.
it's
So
not
so some of
3D.
these
So,
images you're going to see are artist renditions.
hmm.
Yeah, I hope that answers the
Yeah, I
question.
think it does.
Okay, I'm going to go to the next slide. And what I'm showing you here, I couldn't find actually the video to show you video wise, but I think Chris, you and Mike might have saw this. But when they first launched them, there's a certain period of time, because they're going up in the sky, so they're still quite low orbit. And what you're seeing here is a whole train of those things going up, getting into position.
That's right.
Hear me okay?
Yeah, I'm just turning my volume up here, Paul. I guess somebody made a comment that they can't hear me very well, so I'm hoping this is
Okay.
going to make a difference. Just 1 second here. Um,
Okay.
There, I think hopefully I'm coming through a little clearer there now.
Yeah, speak up more. That's what I got to do.
Yeah. I guess
Get
so.
some more coffee. Get some energy going. Anyway, so what we're looking at here basically is what you would see standing on the ground. Maybe not quite as big as this, because this is probably a crop picture. But if you look at the all those little white dots you see in the air, of course those are stars, and then there's a whole trail of those going up, because they launch 60 of these at a time. So they've got a lot of launches scheduled to get these things up in the sky. So you can actually go to, where's the slide? I'll show it to you. I'll skip right to this one. This is on the Heavens Above website. And this is Starlink passes for objects from a launch. So you're going to see them certainly a lot more naked eye when they first launch them out, and you'll see the big trains going out because they're all dropped in succession. So, for example, on the 18th, which is 2 days from now, there's going to be there'll be the start where you actually be able to start to see them will be at 1852, which in real time is is that 6 o'clock, 7 o'clock, I think.
Yeah, yeah, it's 6:52, right?
So 6:52, so it'll be dark. So and they're going to start out at 10 degrees in the sky. You'll see them in the northeast, and then at the highest point, it's going to be this particular one is going to stay quite low at 10 degrees. But if you look at the one on the February the 19th, that one's going to hit 35 degrees. So
Hmm.
that one will definitely be visible in the northwest. So if you can find a place where you can get a good northwest view, which I would say would be the nature park actually,
Yeah, it should be.
because you got a good low horizon there. You'll be able to see these things going up there, and you can see them with binoculars. So if you just go on the Heavens Above website and just go to where their satellite indication spot is, where you can just see satellites, not just Starlink, but any satellites really. You can go up and look and see what satellites are coming by and when they're going to be passing. Anyway, you can get that information there from that one. So basically, we've talked a lot about what you're going to see up there, but who is it that we're talking about? Well, who we're actually talking about is SpaceX, and SpaceX, of course, are the folks that developed the rockets that can go up and have their fuel rockets come back to Earth and land down there. So they're making space exploration a lot more affordable. You're making lots of noise there, Chris.
Sorry, yeah, just trying to plug in my headset, see if that made any difference with my volume. So, go ahead.
All right. Think that guy, on one of those spy movies, and he's wearing a wire and he's scratching it.
Stop eating those bag of chips. I'm trying to talk.
Anyway, so SpaceX, they're set up down there with where they're doing these launches is from the Kennedy Space Center. And on this particular image, when you look at the two rockets on the side, those are the ones that are going to actually get them up in the air. They'll separate from this rocket, and then those will come back and they'll land back down on Earth. And they can reuse those, I think, up to 12 times, I think. So again, it's making space economically feasible. So the type of rocket that you're looking at there is, I think they call that the Heavy Falcon. Let me just see. I'll show you.
Falcon Heavy.
Falcon Heavy.
Heavy Falcon.
That's pretty funny.
Same thing.
That's pretty funny. Anyway, so there's the Falcon 9. That's the one they started out with. But to get those payloads up there, they had to have something with more kapow. And so the Falcon Heavy is the one that they're actually taking those satellites up with. But if you compare that to the Saturn V, that was a huge rocket, right?
Yeah.
And and that's what got us to the moon. So now we're fast forwarding, how many years? 50 years, and look at the progress we made in rocket design. It's just unbelievable.
Yeah, they use 27 Merlin engines, I think, on that one as well. So when they're using the Falcon Heavy, I think the Falcon Heavy went up with his car, the Tesla car. Yeah. So that was the first test of the Falcon Heavy, and I know they've used it since for other satellite launches. I think they're doing a lot of launches with the Falcon 9 actually, for the Starlink ones. But they will be running the Falcon Heavy for some of the missions for sure. When they double up on missions, like they're not going to just deposit 60 up there at a time. There are going to be times where they're going to put 120 up at a time. So they've got a commitment to meet. I think it's 3,000 in the next 2 years that have to be up there.
Yeah, they've got to have a lot up there in order to be able to set the network up, and they haven't even got the software set up yet to be able to bring it to people. So that's still in the works. So the type of satellite that they're using, and here's a prototype right here. And so that satellite, they say they're about the size of a table. and it'd be a big table. Certainly, it's not as big as his car, but they weigh between somewhere close to 500 pounds each. So if you're taking 60 of those up, you can do the math. And not to mention the rocket itself and the fuel and everything else to get all that in the air. It's a lot of weight. So right now, like I say, they're launching 60 at a time, and this is kind of how they look like when they're in the rocket. So there's 60 of them right all lined up, ready to go. So there's 30 on this side, and there's 30 on this side. And that's basically how they take them up. They open up the doors when they're up in the sky, and they just basically dump them out. And that's when you see those big long trains, like I showed you back in this image here. Those long trains are basically when they first let them go out of the rocket, and they're getting them up into orbit. That's what you're going to see.
Yeah, we saw that one night at Jim's house out in Norton. I think it was the first launch or maybe the second launch.
Mhm.
And we had no idea what we were looking at. We were up at looking at Jim's observatory. He had the roof open, and we looked off into the sky, in the northeast sky,
Mhm.
and we saw this train coming by. I said, "Okay, guys, what's going on here? Like, can you guys turn your heads, please, quick, and take a look to make sure that I'm not seeing things?" Because
UFOs.
yeah, I'm about to call Area 51 and see what they did. But yeah, I mean, just I had no idea like it was going to look like this. So it was amazing. And we waited for 90 minutes, and it came back over our heads the second time.
Yeah.
So we were down in front of his house, and it went the opposite direction. Like this was going right to left, and then it went left to right from behind me the second trip. So it was really amazing to see that train like that. I said, "Wow, this is going to be cool to see all these go up there." And now I'm starting to think, "Oh, not cool at all."
Yeah, I haven't seen it, but you can certainly look at it through the heavens above sight to see when they're gonna be going up for some more. What they're actually gonna look like. This is an artist rendition, but when they're up in space, so you can see there's little ones all over the place. So they're single-sided solar panels. They're not using two solar panels; they're just using one. And the reflectivity, as everybody knows, is the problem with them. It's something that they didn't even consider when they built them. And of course, it's everybody who's looking up in the sky that's seeing it. So they had put together one that they wanted to see if it was going to be as reflective. They called it dark sat, and they sent it up. And the issues that they had with it was it darker? Yes, but the trouble was because they were trying to darken it down, they were running into heat issues.
Yeah,
So that's something that they're going to have to work through. Uh,
absolutely.
I- yeah, so that reflectivity is the issue that we're dealing. If there wasn't any reflectivity, it wouldn't really be an issue.
Right.
So
Yeah, no, that's a good point. Um, and even if they were, so they did talk about painting them black. I mean, if you get a long exposure photography, Paul, you're into
hmm
long exposure. You do hours at a time.
hmm
I guess maybe what I'm trying to say is that do you get satellites through your shots now that are less reflective than you used
Yeah,
to?
we do. Satellites. I mean, you can see them naked eye, so you know they're going to be picked up by your camera. But because of the infrequency of satellites, there's certain algorithms rather, that are built into some of the stacking software that you can actually get rid of those things. If you've got enough pictures stacked, there's an algorithm that you can choose that if you have a satellite running through it, you can actually get rid of it. So instead of having to throw away that particular frame that you might have spent 5 minutes on that one frame, you can keep it. But when you're um, dealing with the amount of satellite streaks that we saw earlier in these photographs, like this one here, for example, I think we got a lot more to deal with.
Hmm.
Because there's going to be certain elements that are going to be covered in your image in that particular frame that you may not be able to recover. Because there's going to be so much streaking going on, and the brightness that these have, and that's something I didn't research. I'm going to have to look at it, but the brightness that these are, I believe, are actually brighter than the typical satellites that we see.
Right. I had another. I read a little bit about the Minor Planet Center. The ones
hmm
who are tracking asteroids are really concerned about this as well, because as they get close to the 30 degree, as they're close to the horizon, they have to be sure of what they are, right?
Yeah,
I mean, they're always catching asteroids that are going by the planet after they've already gone by the planet. So,
that's right. Yeah, and yeah, there. I've gone on a few sites, and actually, I think his name is Thacker, the fellow that's in Halifax. He was on live or CBC News or ATV News this week, and he was talking about this very thing. And he's talking about what they're doing or trying to do, and they're trying to work together on it. Right now, it's more in the favor of the satellite companies because again, it's big business, right?
hmm,
And but I think over time they will come to some kind of agreement to it to some point, and maybe one will aid the other in developing some kind of software that'll help take care of this, or maybe they will work on getting them all darker. It's hard to say. It's a long ways out at this stage, but um, but the satellites themselves have a 5-year expectancy. That's kind of basically what their usable life is supposed to be. So they're going to shoot them up. They're going to hang around that 350-kilometer height range, and basically they say that they're 95% demisable. So that just simply means that once they've used up their life and they're ready to go out of commission, that 95% of whatever they are will basically just evaporate, coming back down to Earth. So
okay.
so that's a good thing.
Yeah, it is a good thing. Yeah.
'Cause there's gonna be a lot of space junk if not, right?
Absolutely. Yeah, and I mean, there's always a chance of them colliding too. I mean, I know they're autonomous, so they seek their own position apparently, but there's a lot more opportunity now for collisions as well. And of course, when two collide, that means tens of thousands of more pieces out there, right? So
Yeah, I think they had almost had a collision not that long
yeah,
ago.
they
They
did. Yeah.
Yeah, there was one that was quite close. Did I show this one here? I'm not sure.
Michael Stewart
No,
says
I
there's a
didn't.
scheduled launch for tomorrow at 11 a.m. Atlantic time from Florida. Oh, thanks,
Yeah,
Michael.
yeah, that's the one that they did that was delayed from yesterday
Hmm.
because of that stage 2 rocket issue. So this image here is again it's a rendition of what it will look like, but that in fact is a satellite. And you see the one in the background, it's actually opening up its
All right.
um, solar panel,
Mm.
but once they're totally open, they're flat like that. And they're fueled by, believe it or not, kryptonite.
Kryptonite.
Krypton.
That's the problem.
So if it's good enough for
Yeah,
Superman, it's
we're Superman when we need him.
anyway. They're just run by little ion thrusters, and krypton or krypton, or I'm not sure how they pronounce it, is what they actually use for the fuel on those. So that
Huh,
was kind of
it's
that's
interesting. Yeah.
kind of cool. Yeah. Um, and let me see. If there's anything else here that I wanted to.
So Mike said two satellites crossed within 14 meters of each other. Thanks, Mike.
Wow. I
Yeah, that's
mean,
close.
in space.
That's close in space. Mm.
Oh my gosh, that is so close.
So yeah,
Um,
it's the fellows that are like, and I think even like the International Association of Variable Star Observers.
mhm.
Those people who observe stars that are variable, pulsating, that type of thing. They're showing their concerns, and the IAU I think is presenting their concerns to the United Nations conference in October this year. So
Yeah.
they are speaking out about it a bit. I mean, I don't know how much they're going to talk about it. I know they're promising to express their concerns about it. So
Yeah, there's a lot of um, what's that word? Uncharted territory
mm,
with this stuff because there are so many things that you wouldn't even conceive would happen up there, and then all of a sudden now that there's going to be so much traffic, not to mention competition.
right,
You know, pretty soon, there's going to have to be a regulatory body, which I'm sure there is. FCC, I think,
yes,
takes care of most of
yeah,
it, but
they do,
uh,
yes,
I mean, when it gets competitive up there, I mean, I can see some some long pieces of paper that are legal as to what you can and can't do up there, which is going to be necessary for sure. But
and that's the thing about the FCC is that all the FCC is doing is really leasing providing a license for that frequency. They're not really stating about how many satellites there will be up there.
well, that's
So
it.
yeah, they're just providing a license to operate on that frequency. So is that the right power, to be in charge of the number of satellites? Because really, it's a global thing. one company from one country gets to control, the world's light
Well,
pollution.
that's it.
So that's the concern.
And that was one of the things they talked about on that program yesterday.
Mm,
Because Starlink originally was supposed to have their orbit was supposed to be between 680 and 800 miles up. But because of um, growing competition concerns, they decided that they had to drop them down to 340 miles up.
okay.
So that's quite a little difference. So they had to, of course, because then it becomes a non geostationary orbit, right?
Right. Right.
And then they had to express their concern to FCC, which they presented it to them, and within a month, I guess, they had the okay to drop the satellite. So right now, there's really not a lot of traffic up there, but
Mm,
like I could say, this is going to be, for them, probably a little bit of a conundrum. But for us astronomers down here on Earth, I guess my takeaway from this at this stage is no, I'm not going to give up taking pictures of the night sky
mm,
because the satellites are going to be relatively low and going to be in the wee hours or just the beginning hours of the evening.
right.
And both hours, probably not so much in the beginning hours, the wee hours may have an issue with you, but we like to shoot closer to the zenith
Mm,
as much as we can and follow it along. So a lot of these satellites may not be an issue for us, but I think for the professional astronomers, the people in Chile and places that have these, huge observatories that, take every moment they can of darkness, they're the ones that will have a little bit more of an issue with it, I think, at this stage.
absolutely. And I guess let me see what's coming up here for comments. Mike says that's called visual environmental pollution.
Visual environment, that's right.
Cool. Yeah, it is the term for it. And
I
David
do
Casher
have
says, oh, sorry.
I do have a picture that somebody posted. I got to show this.
Okay.
And this is a picture of, is it Elon
Elon.
Musk?
Yeah, Elon Musk. Yeah.
So here it is.
Yeah.
So they
Oh,
said, what would it be like if you were, took pictures all day long and you had your advertisements going and they had Starlink trails going through them? How would that make you feel? Anyway, I
yeah.
thought that was kind of cool. So I
So
thought I'd post that.
Dave McCashin asks, why not geosynchronous orbit? Uh, why not geosynchronous instead, I guess. Not sure.
I don't know because what they're talking about is when they talked about dropping the height of the satellites, they also talked about limiting the frequencies that they're going to be transmitting on.
Okay.
And again, I don't understand that part of it that much, but I know that there was certain bands that they were going to not be using at that particular height because there are other satellites in and around that area apparent or that height or that orbit height that could be affected by it. Because I don't think that the ISS is actually not that far much further out in orbit.
Yeah,
I
it's
think
not.
it's at around 400, so it's not that much different in the height. So anyway.
Well, maybe they can get a grappler arm or something, and reach down and grab them onto them on the way by. One of those really strong magnets you get on the poles. And
Yeah, that's it. So anyway, so that was something that we Chris and I were talking about earlier, and we thought, I think just to let people know, because I'm sure everybody's hearing all kinds of funny things and getting bits and pieces of information. But in terms of how SpaceX and Starlink is approaching this, because they were the ones that were sort of the catalyst of it, the first ones out there with it. We thought we'd bring this to you and just kind of see what research we found on it. So.
Murray asks, how many of these are Bell satellites? I'm not sure, Murray. I'm not going to touch that one. Yeah, I'm employed by Bell. He knows that. So
All right.
we'll leave that one alone for a private channel later, maybe.
That's it. That's it.
So we're back. Okay. Thanks, Paul. That was great.
Yeah.
Lots of information there. Lots to absorb. Lots to digest over the next few years for sure.
Yeah.
Yeah. I mean, we're gonna, we may even see the difference in places like Mount Carleton ourselves for night observing, but hopefully not. Hopefully it's not going to be at that level for us. But certainly for guys who are doing some astrophotography, long exposure will affect them, and these professional astronomers all over the world are really concerned about it, and probably rightly so at the moment.
Oh
So
yeah. Oh, no question. You know, and it
Amazing.
makes everybody scared because it's it's the unknown,
Hmm.
and it's like anything else that first gets up there. We all have concerns, but I think overall, in time, they'll all come around.
Yeah. Okay, so we ready for our next section?
Yeah, I am. Just let me get my notes ready on it because there is one thing I have to be able to see.
Okay.
Here it is. Okay,
So I want to share your
and
stuff.
I'll start sharing my screen again then because
We're going to
we're getting ready for.
Rosanna's Fun Facts.
Sorry, Rosanna.
Dun, dun, dun.
We're kind of doiling it for you, but we'll eventually get audio on this sometime.
Yeah.
So yeah, so this week in Rosanna's Fun Facts, actually, Rosanna wrote a little letter um, regarding what we want to talk about this week. So I'll read a little bit of the letter first, and then I'll get into some of the photographs that she sent because I think this is kind of a cool topic. So she says, "Hi, Paul. Time to catch some rays." So I think everybody's getting tired of the winter and the shoveling and all that, and we all appreciate the sun. So she says, "Looking forward to spring has me thinking of catching some rays, but from a whole different perspective." So last fall, the same fellows, in other words, Chris and Mike and myself and Kurt and Phil, uh, and us here at the Sunday Night Astronomy Show, provided the moon course at in St. John here, featuring 40 to 50 moon features to try to find and observe. And she really enjoyed the course. She had a lot to learn. And RASC, she also mentioned RASC also offers the Explore the Moon, which is an introductory lunar observing program.
Hmm.
But if you're a long time first say my new tongue, if you're a long time lunar observer or even being a newbie, there's a whole new list of features to illuminate your life. And what these are, and I'll click up the first picture, and they're called lunar sun rays. So, so that particular illustration there shows the most prevalent way that lunar light rays form. Before I get into explaining that, I'll go back to what Rosanna wrote. So she says that the lunar sunrise and sunset rays, they're a rare phenomena, and they become visible when shafts of sunlight shine through the gaps, which would be these little spaces right here, or holes in crater walls or mountains. So when the timing is just right, a spike of light can cast across a crater floor. So that's basically what you're seeing right there in that illustration. So the sunlight's coming in at a specific angle, and it has to be very, very low, of course. And it breaks through whatever happens to be the crevice at that point in time, and it gives you those really cool light rays that you can actually see.
Hmm.
And this happens infrequently and only when the sun hangs really low in the lunar sky at sunrise or sunset. There's a website that you can go to see. There's actually 82 of these phenomena that you can see from the beginning of the lunar phase at the beginning of the month to the end of the month. And there's 82 things you can look at there. And if you find one that's not on the list, they'll actually publish it for you too.
Oh, wow.
So anyway, so this particular illustration shows a little bit of what she was talking about there. This next illustration is the wrong one. There we go. There's an artist rendition. So here's somebody had enough time that, so obviously these just aren't coming and going really quick. This person had enough time to be able to actually do a detailed sketch of the, I think they call it Magenis crater. And it shows the sun rays illuminating part of the crater's floor, which is basically, so the ray in this particular one would be coming from this side, because I think the rays always come from the bright side of the moon, and you're going to be set up quite close to the terminator. So the terminator would be on this side. So the light rays are actually shooting through this way, but it's a really nice feature to look for because it's something that you can look for each month, which is really nice. So here's a smaller, so you can see how close it is to the terminator, right?
Yeah. It's,
So when you're that close to the terminator, and it has to be because of the sun angle and all that stuff, just like when we view things, we always like to view close to the terminator because that's where the greatest shadowing is. And the same is where these sun rays are, sunrise rays are. So it's very, very cool. So she added also in here, I'm assuming she was getting this from a part of it from a book. So before full moon, there's all of these features. So you can see there's the Hypatia double ray, the Burnham ray, the Gemmaphreyus ray. So these rays are all named by somebody, and it tells you there basically. So if we just look at one, for example, let's look at the Gemmaphreyus ray, Freesius ray.
hmm, Mr.
The
Freeze.
sun ray is the result of a break in the eastern wall on the southern highlands crater, which allows a shaft of light to shine across the crater floor and illuminate three small craters on that particular crater western rim. So tiny ridges only several feet in height cause this ray to have a few dark bands on it, roughly perpendicular to the ray. So and I looked at this and I thought, well, does that mean that you can see these at any time? You can look at all these at once, but no, you can't. What it is you have to follow the moon phase.
Hmm.
So when the terminator is really close to here, so that particular phase of the moon, then you can see that Hypatia ray. But as the moon starts to grow further, as it starts to grow further into its phase, then wherever you see these little lines and dots, it would be that particular phase close to that terminator is when you can see that. So that's the before full moon side, and then there's the after full moon side. So there's a whole bunch of other ones there. And I think if you spend some time looking at it, you probably discover some of your own. But it was just an absolutely interesting a way to look at the moon that personally I've never looked at the moon that way, and I would never ever think to look for those things.
Well, I mean, yeah, even when you're talking about the moon and the side that we see alone, there's over 300,000 craters on the near side of the moon that we see that are over a kilometer across each. So we're
Hmm.
talking about a whole lot of craters here. Like we're talking about billions of them because those 1 kilometer craters have, half a kilometer craters inside those and 100-meter craters inside them again, and they just keep building. So I'm sure that you could spend a lifetime just discovering these.
Absolutely, absolutely.
And again,
So
as your terminator line moves across, is where you're going to be able to see the most of it because that's when sunrise is happening on the moon. So,
yeah, exactly, and the angle has to be just right for that to get through. So although one may say observing lunar light rays yields no scientific value, the rarity and challenge would certainly provide some fun. And I agree. So that was this week's Rosanna's Fun
fun
Fact.
fact. Excellent.
Thank
Dun,
you
dun,
very much,
dun.
Rosanna. That was absolutely awesome. I
That was
really, really
awesome.
enjoyed that one.
Well, good stuff. Like that. Alrighty. So where are we at? We're at about 20 minutes to. Um, Perhaps I could bring up my presentation here. Are we still live there, Paul? Yep.
We
You're still
are
with me? Okay, good.
live as I can be.
I just wanted to, yeah, I can tell that. I just wanted to talk a little bit about, maybe you can watch the YouTube comments call because my other screen has got my presentation up.
Yeah, I'm going to try and get tapped in here.
Okay. So tonight I just wanted to talk a little bit about what's happening over the next couple of weeks in our February sky. I know we're into February now, but I mean we're only 3 weeks away actually from the time change.
Wow.
Yeah, 3 weeks.
Yay.
Yay! Boo! Yay for some, not all of us. Yeah, we don't like that. Okay, let me see what I got here. So change the display settings to swap presenter here, and that should give you the full screen view. Is that right? Oh,
Yeah,
no.
I'm not sharing now at all. So
Okay, so I'm not.
you're
You're
good.
not seeing it. Are you seeing it now?
I am seeing it.
Okay,
Yes.
good. Because I didn't click share my screen, but okay, perfect. So what's up in our February sky? And I always like to start with this one. This one tends to get people a little bit confused, but if you picture this as a view of our solar system from above. So we're all rotating around the sun in the same direction. We're all heading around counterclockwise here. Maybe you can see my mouse. All heading around counterclockwise, and then this little inset here is this piece right here, which would be the four inner planets. Actually, this comes from the website heavensabove.com. So if you go to that website, you can take a look at and just click on the planet button. You'll get this view. So what's going on here is that here's the Earth out here, and our sun, of course, in the center, Sun, Mercury, Venus, Earth. And what I wanted to do was really show you why we see the planets that we do at the times that we do at the present time right now. So let me spin ahead here. And I'm going to take a look, first of all, at this planet summary, which is a really nice page on Heavens Above. I go to this quite often because I want to know what planets are going to be up this evening. So I look at the rise and set times. So here's my, for instance, Mercury rises at 7:52 and sets at 17:12 tonight, or 19:12, which is 7:12. And as you change the dates up here, these will all change, of course. It even tells you what constellation they're in. So right across the sky, I can look here and I can see that Mercury set at 7:12 tonight. Venus doesn't set until 9:34. Mars is up at 4 o'clock in the morning and up till 12:54, and Jupiter right across. And we'll tell you what constellation to look for them in as well. But the other things that are here are this thing called inferior conjunctions. So that's when the only two planets that can be at inferior conjunction are Mercury and Venus, because those are planets that are inferior to us in the sky. So they're between us and the sun. So Mercury is going to be at inferior conjunction on February the 25th. And I'm going to get into the slide here on why that means something, because as we get closer into the end of February, we're going to see that Mercury is going to disappear out of our western sky. And that's because it's getting between us and the sun, so it's not going to be visible. Venus actually doesn't go down to that point until June the 3rd. So we've got lots of time yet to enjoy Venus in our southwestern sky. And we'll pay attention to Neptune out here, because that's actually was it Neptune? I'm sorry. No, it was Uranus, Neptune. Yeah, we're going to go back over one more slide. We're going to pop out to this one. Here's my paint drawing. I'm really good at paint.
You're good.
That's about all I know.
You're good.
Yeah, graphically, how I'm trying to explain this is, here we are. So we got the sun, we've got Mercury, and we got Venus, and here's a nice little blue Earth. Again, we're all rotating counterclockwise as we rotate around the sun counterclockwise. So let's picture that we're standing right here in this little X. And it's early evening, and we're looking back this way. So we've got the sun has set in the sky, and then we see Mercury and Venus in our sky. So let's go to the next slide. And hey, look at that. There's Mercury and Venus in our sky. So the sun has set behind us, and here's Mercury in its orbit. And you can see now that it's getting very, very low in its orbit. It's almost, it's going to, again, go into inferior conjunction on the 25th of February, so it's very close to that. So Mercury doesn't really appear very high above the horizon anyway, most times. Depends on how steep what we call the ecliptic is, that line that the planets seem to move across. So in the wintertime, that ecliptic is fairly high, and in the summer, the sun is low, so it's the same. It's following the same line. So in the daytime, the sun is low and the planets are high in winter, and in the summer months, the sun is high and the planets are low. So they switch. So right now we see that Mercury is has already gone by the top of its orbit. It's what we call that is eastern elongation. It's the farthest east that it can get before it starts to drop again. So now it's dropping back down, and it's going to go between us and the sun on February 25th. So back to our drawing again, and why I wanted to go back to this now was to say, okay, we've covered the sun, we've covered Mercury and Venus. We're still spinning around. Hey, we're looking out into the nighttime sky now, and there's Uranus out here in the nighttime sky. So let's take a look at Uranus, and there it is. It's up in Pisces in our in our western sky as well, southwestern sky, I guess. Now Neptune is not visible because Neptune's going to be at superior conjunction on March the 8th, so it's barely visible now. But let's take a look back at where Neptune was. So here's Neptune way out here, and there's the sun, and here's us going around the sun. So as we get to this point, Neptune's going to be on the opposite side of the sun as us. So it'll be what we call superior conjunction. Okay, past that point, and now we're going to spin over to our morning planet. So here we are at the little X again, and all of a sudden we're rotating around, and before the sun pops up in the sky, we're going to see a few planets pop up: Mercury, Jupiter, and Saturn. in that order. So Mercury will pop up first, or Mars, I'm sorry, Mars will pop up first, then Jupiter, and then Saturn. So if we spin to our next slide, here we are. Mars popped up first, Jupiter, and Saturn. And this particular one here is tomorrow's view. So tomorrow we have Saturn, Jupiter, and Mars, the waning crescent moon, and the bright red star Antares, which is really Antares means the rival of Mars. So when Mars and Antares were close together, they looked almost the same color. They're both red, very reddish in color. So tomorrow morning, if you get an opportunity to get up a little bit earlier, sunrise for us here in St. John is until about 7:30. So you've got some time. Here's 6:30 in the morning. And at 6:30, we would certainly be able to see the waning crescent moon, Mars, Jupiter, and Saturn all in a really nice line. So a nice display of planets for the rest of the month for sure. And these will continue to rise up over the next few nights, or the next few weeks actually. So we'll get a better view of Saturn in the morning and Jupiter and Mars. Now Mars is going to be very tiny in a telescope, but it's still visible. So now here we are to, this is the next day. Where was I at? I was at Tuesday. No, I wasn't. I was at Monday. 17th, Tuesday. Yeah, Tuesday. It even says it there. Look. So this is our sky on Tuesday. So the moon has moved a little bit closer because the moon rises about a little bit, an hour and a little bit more sometimes each morning, so each night. So on Tuesday, though, the moon is actually going to pass in front of Mars. We call that an occultation. So the moon is going to occult Mars from 8:58 until 10:16 on Tuesday. Now, some say you can see that. So if you have a pair of binoculars, you're going to be looking at a bright sky, of course, here from 9 o'clock till 10:15. But what's going to happen is that you're going to be able to see Mars be passed by the moon. The moon will pass in front of Mars. And then it's going to take about an hour before it pops out the other side. So that's our sky on Tuesday. Again, we're still in the morning sky in the southeast. If we step over to Wednesday, this coming week, we've got Mars, Jupiter, and Saturn in a line, and the moon has cuddled up to Jupiter at this point. So we still get a waning crescent moon here, close to Jupiter. So a really nice opportunity for a nice photo there as well, if you're into taking photos of planets and the moon together. And who isn't, right, Paul?
Oh, yes.
Here we are into the February 20th, so we're at the end of the week on Thursday, and we've got Mars, Jupiter, and Saturn cuddled up to the moon again.
Wow.
That's our last view of the moon as we go into a new phase now, so that'll disappear. And then if we go ahead, look, I'm just going to take you, so as this is a little video I picked up from NASA's website, and NASA has a lot of these out there that are free to download, but it's showing us the phases of the moon and why we see the phases that we do. We always see the same side of the moon. The moon is in synchronous rotation with the Earth, so it takes the same length of time to rotate around us once as it does to orbit itself on its own axis. 1 second here. I just lock up? I locked up. You there?
Oh, no, you're going good here. Well, no, you just locked up here now.
Yeah, hang on a second there. My PowerPoint just rebooted. Document recovery. Oh, wow. And that's the way the night goes, eh? Let's try again here.
This is that segment of our show, right?
This is that segment, yeah. The current slide. All right, let's go back. Just bear with me for 1 second. All right, we're back.
Yeah. You're back.
Yeah, okay. So let's zip ahead to the slide that I was trying to get to.
I think it was those Starlink satellites that kind of.
Let's say that's what it was. Hey, here we are. Okay, let's do this again. One more rotation. We'll see if it works this time. So yeah, it's basically just describing the phases of the moon and why we see the phases that we do, because the sun, of course, is coming off to the left-hand side here, and so right there we're at first quarter moon. Now we're slipping into a waning crescent moon, when the moon will disappear. Of course, it disappears in our daytime sky because it's so well lit. The sun is so bright behind it. It's actually about 5 degrees above us or 5 degrees below us at any time. until it passes the two nodes that it takes it from up above us to below us. Here's we are at third quarter, and we're approaching full moon phase. So kind of a neat little thing. If you want to show that to some kids, NASA's got it up there on the YouTube channel. So it's pretty neat to explain how the moon actually works. And from there, we'll take a look back now again to 26. So we're talking about a week from now, where we've got another beautiful Venus and the waxing crescent moon in our sky on the 26th. So just like it was last month, where we had Venus above the crescent moon, we're going to experience that again this month, and again, I believe, next month as well. So another real nice photo opportunity. This is the moon at about 2 days old, I believe. And if we watch that over the next couple of days, we'll see that it flips over to, it's a little bit to the left of the moon. I'm sorry, the moon is a little bit left of Venus, and a little bit larger in the sky, and then again the following night. So that's what we got coming up in our sky over the next week or so. So keep an eye out for that over the next couple of weeks. Of course, again in 3 weeks' time, we're back to our time change, so we're spinning ourselves out of winter really quickly now, and our evening skies we'll be losing them, but we have to put up with that, I guess, Paul.
We do, we do. But that's okay. The warmer weather's not a bad thing either.
That's right. Okay.
Oh, Michael Stewart says that little glitch. You just blame IBM.
Okay. I gotta blame somebody. Kind of stuff happens. Oh, so yeah, we had a couple of photos, I guess, Paul, maybe to bring up now. So,
Oh yes, 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 yes.
So a few people did send in some photos, and what I'm going to bring up is my last slide here, first of all. And if I can get back to it again. If it'll let me go to the current slide, hopefully it will. Slideshow from current slide. And not gonna take there. Yeah, so send your photos to Sunday Night Astronomy Show, all one word, at gmail.com. The Gmail address does work now. There was a hacking problem, apparently.
Perfect.
Hackers. Anyway, it's back up online. It's up and running, and I've got a few photos to take a look at tonight, or that to share tonight that were dropped off. So if you'd like to send some photos in, we'd love to show them up on the page on the channel here, and just talk about them a little bit. So send your photos in to Sunday Night Astronomy Show at gmail.com, and let's take a look at what we got here tonight. So I got to share my screen. You're able to see that stuff anyway, I guess, Paul. Eh? You're seeing it.
Well, let's see. I see me.
Okay.
I feel like what's her name? Anne Raimi with a little mirror.
Miss Anne.
Miss Anne, yeah.
No, it was Romper Room, wasn't it?
Upper room, yes.
Yeah,
We'll
that was
see
a
you.
different one.
She saw a lot of people in that mirror. I don't know.
She did see a lot of people. Yeah. I don't know. Okay, so we'll avoid that topic and see if I can bring up a photo here. So
Great.
Here's the first one. You see that okay? Or are you able to see it? No?
I'm just waiting for the delay.
Okay.
There we go.
Okay.
Oh, perfect. There's the moon. Looks great.
Okay. You're seeing it on YouTube.
I am.
Okay. Let me. I wonder if I need to share my screen. I guess I don't need to. So. Anyway, that's from Irene Doyle, moon from February 10th of earlier this month, I guess. So.
Great shot, Irene.
Nice shot, Irene. Yeah, very well done. And we've got a couple of shots here from Robert Cadet. I'm going to bring up his shot here of the Orion Nebula. Awesome photo. Zoom in a little bit. So, of course, the Orion Nebula is underneath the 3 stars that make up the belt, and that's an area. It's a stellar nursery. It's where stars are being formed right now. Lots of color in there.
Oh yeah, yeah. It's a pretty target to shoot.
Nice job, Robert.
Yeah, great job, Robert.
Okay, next we've got another picture of Robert sent in of the moon. Wow. This is DSLR photography, I guess, through the scope. Lots of detail there.
Oh yeah, wow. I saw that one last week. That's a really great shot. I like that he's got the natural colors in it.
Yeah.
Because a lot of people just shoot it in black and white. But he actually got some really nice color detail in there. That's a terrific shot. Nice clarity, lots of ejecta ray on it.
Sinus Iridium up there, and Copernicus.
Yeah. Yeah, the bear that nobody can see but me.
And well, that's true. All right. So thanks, Robert, for those. And let's see if I can get another one up here. I think I get a couple here from Trudy. So Trudy sent us in this one. This is a great shot. This is a spot called Split Rock down in St. Martin's area. She's going to correct me because it's not St. Martin's.
Oh yeah.
Oh, what does she call it? Oh, I don't know. Whatever.
It's Black River.
Forbes Beach. Oh, that's what it
Forbes.
is. Okay.
Oh, standing where she is.
Yeah.
Forbes.
Oh, yeah.
Yeah.
I know
Yeah.
I know where that is now. I remember. I've been there.
Yeah.
Yeah.
Isn't that a fantastic
What
photograph?
what a spot to look at that. That's good
Oh,
timing. That's good timing right there.
that is just perfect.
Must have been planned for that one.
Yeah. Well, she you know something. She looks at a lot of charts, and she knows when to go out. If you're ever in doubt, or if you haven't got time to look, call Trudy.
Mm, exactly. Now look at how big the moon looks there. So that's the moon illusion, right? So
Yeah.
uh, that's what people see when the moon is down close to the horizon, and it's because our brains play a really strange trick on us. Because there's a whole explanation. If you took two railroad tracks and you end them up at a point, and you had a ball at one end and one at the same size ball at the other end of the tracks, with the one that's nearer to you would look smaller than the one that's farther away. But it's all our brain playing tricks, and our brain believes that the moon is much closer to us because it's comparing it against the mountains and the trees and everything in this case, and at the horizon. Of course, when we move the moon up to the sky above our heads, our brain doesn't have anything to compare it against, so it looks so much tinier. So when you do see a moon like this popping up, it doesn't have to be a super moon, just any moon that's at the horizon, because it'll always look big like this. Um, Make a fist, poke a finger down through your fist, and then hold that up to your eyeball and take a look at the moon that way. And you'll block out all of the landscaping around it, and you'll see how tiny the moon really looks through your hand. So that's what cancels out that moon illusion. Or they said you can turn around and look at the moon through your legs. Bend over, look at it through your legs. But I could never do that. I just end up falling on my head.
I call it being mooned. I don't know.
Yeah, that's when you're mooning the moon. I guess. Yeah, you actually moon the moon, and then you find out.
But too on that, Chris, is what really I find interesting is the color because of the light refracting at that height, like when it's in that low on the horizon.
Right.
But not only that, but how the moon goes misshaped.
Yeah.
It just takes on this sort of squashed beach ball kind of a look, and once it starts rising, it loses all that. As it slowly rises up, it's really quite something to behold. And where she took the photograph of that, to stand there and watch that rise
Mm.
and change from that gorgeous red orange to the yellow that it'll eventually get to is just something else.
Amazing. Very nice shot. Yeah, and
Yeah.
that red, I guess, it's like sunsets, I guess, too. I mean, sun isn't red. It's white. It's all colors of the rainbow, but as the sun gets lower in the sky, it's passing through more of the atmosphere. So the red wavelengths of light are longer, and they'll reach our eye, where the blue wavelengths of light they get scattered in our sky and gives us a blue sky. So yeah, that's the effect that we're seeing there. And as it gets up higher, we're going through less and less atmosphere, so we start to see the true color of the moon. But excellent shot. Very nice, Trudy.
Excellent.
And we got another one here from Trudy. She brought up Mars at opposition. So there's Mars over here on our left-hand side. And Mars is actually casting a shadow on the water there, or a brilliant streak on the water, just like the moon does. It's reflecting back onto the bay. That's amazing to see Mars, a planet, offering that. I mean, Mars, especially Mars, because Mars is never really that bright. Venus is really the third brightest object in the sky behind the sun and the moon, right? But when we get into Mars, you're looking at something a lot dimmer. I mean, for it to light up the ocean the way it does there, and the Milky Way off to the right, of course.
That's a beautiful
Really nice
photograph.
shot.
Yeah. She just missed Antares, because Antares, if you look at the prancing pony, he's up on the side there in the Milky Way, and that will actually the front legs actually stretch right out to Ophiuchus. Did I say that right?
Ophiuchus, yeah.
And yeah, so it'll be down in here. I am pointing at the screen like everybody can see me. More coffee, please. Anyway, it makes if and this is what, like when you were showing earlier in your photographs or in your night sky coming up,
Mm,
to be able to see Mars and Antares in the same field of view, it's just it's
yeah,
beautiful,
amazing. Nice shot. Very nice.
beautiful shot.
The last one I got here is there's a little bit of a story behind it, I guess. So it's this one here that I showed last week that I had taken at uh, at the Irving Nature Park barn. So there's a barn up in the area of the Irving Nature Park. I'm not sure where the property owner is of all this area, but it's we're not quite looking at Sheldon Point there. Sheldon Point would be off to the right, but that's the area down around Sheldon Point. So I grabbed that photo, and then somebody sent me an email, a message asking if they would mind if they painted it. I said, sure. I mean, I never never really been asked that before. So anyway, the person who painted it is Anka Reed, and she has a painting shop called A. Reed Fine Art and Decor. And I'd like to show you the result of that painting.
Well, a great photograph to begin with.
And there's the painting. So Anka did a absolutely wonderful job there.
Oh,
She picked up all the grass here in the side, the waves here,
wow,
even in the clouds. And Anka
fantastic.
offered me this as a gift, so I'm just beside myself now to say thank you so much for your generosity in this offering to me. I can't believe it.
It's amazing artwork.
Can't wait to get that up on the wall. And she does some amazing work, so you can follow her at A. Reed Fine Art and Decor. She's in St. John. She has a little studio here in St. John. She does some amazing landscape work,
Wow,
and she has some really nice. She actually does photos of pets or the portraits of pets as well. So if you have a pet that you'd like to get a portrait of, she does that as well. And she's has a website with a lot of photos on there, or a lot of paintings. I'm sorry. So um, this is just stunning.
no, it's absolutely beautiful.
So let me take it back again to the original, from that one to this one.
I can't believe how much she's captured that whole essence of the lighting and
Mm.
oh, what a
She says she likes to do the contrast part. She loves the lights and darks. So she's even that cloud bank there.
mhm.
She caught that in the final
Oh, the
image as well.
bushes and stuff too that she got.
Mm.
Oh, just fantastic. You're lucky, Chris.
I am very fortunate. I'm still
Absolutely, that's
so beside
incredible.
myself, actually. I can't believe it. So
That
it's
is
amazing,
incredible.
and what an offering. So uh, Anka and her family's going to get a private viewing at the Saints Rest Beach sometime coming up soon.
She'll
for the whole
really enjoy
for the
that.
whole evening. I hope so. So I just wanted to share that. That was an amazing touch of generosity. So thank you so much for that.
Fantastic.
All right, let me get back now, Paul, to you again, I guess.
Well, we're coming up. We're just a little over 9.
Okay,
So, I mean, I can do that one next week. We don't have to do that now.
okay, let me get these closed out of the way. There we are. Back to you. Okay. Yeah, would like to do that, or yeah, we're at 9:03, so we could say that's a night for now, or unless you want to go ahead, Paul. Doesn't matter to me. People are still on here, so it's your call, pal.
Um, okay, we'll do this. I'll do it very very quickly because it was just a quick thing anyway. And basically, what I wanted to show was um, when you're doing astrophotography was just something I want to talk about in terms of being able to use it for observing. I'm not really an observer. I will start it out with the camera and stuff first. And to be honest, I'm still learning a lot about the night sky, and hanging out with Chris and Mike and everybody is it's really gaining me some knowledge. But I remember reading something at one time, and it said that a lot of people use astrophotography of their means of actually observing because you can see so much more in a photograph than what you can see with the naked eye. And on with certain things, and, not so much planets and that, but certainly deep sky things that you don't see all the colors with. So what I want to show here, there we go, is this picture of Andromeda that I took. And it's not that it's an exquisite photograph, but I want to show you what it looks like when you actually get into it and blow it up a little bit. So here's the photograph itself. Again, the angle and the size of the chip that I used and the camera were not quite small enough to give me the full field of view, but that's okay because it gave me an opportunity to take some higher resolution opportunities in different parts of this galaxy. So all I'm going to do here is I'm just going to kind of walk into it a little bit, and because I can go into it this deep, I'm probably about maxing out. Yeah, there, I'm starting to see some digitize. I'll go back one. There we go. That would be 100% of the image itself. But what I wanted to kind of point out was you can start to see some very interesting detail that I didn't know was in and around Andromeda. For example, if we go up to this corner, look at this bright star and just drop down just a little bit, and lo and behold, there's a nice sideways, looks like a spiral galaxy right in here. So, and there's another one. If we go up across this side, I found, where are you? Because they're very tiny and you got to look for them. Um, I'll find it in a moment, but I guess the point, yeah, there's another one there.
Yep, that's it.
And but the point I'm making is when you want to look at a galaxy and its structure, well, then you can get really into it and you can see those nice dark dust lanes, and in and amongst those dust lanes in this particular part of the structure, they're actually terraced. So there's different levels of these dust lanes that are in and about Andromeda. And as you get further and further out, then there's a lot more lighter gas, and that's when you get into that bluer region. But in and around Andromeda, when you get this close, you can start to see all of these gorgeous little star clusters, and they're everywhere. And basically, there's over 300 billion stars in and around this galaxy. So, so there's stars here that we can't resolve with the camera that I used, but or the telescope that I use, but you can sure see a lot of them in and about there. So when you look at it and you just take your time looking at it, you can just walk your way up and through the galaxy. And if you like to observe, but you really want to get into the structural details, maybe look at the different star formations, look at these little asterisms you can come up with. You get to the top, and as you get to this end of it, you can start to see a lot more of those gorgeous clusters that are in and around Andromeda. That's the kind of thing that you can do with your photography. So, you take a fair bit of time to do this and get it, but then you can spend virtually hours just looking at that photograph, going over it. And if you want to get a little scientific with it and try to discover things or look at things, I mean, that's the beauty of photography. That's the things that it offers you. The other thing is this galaxy right here, M110, and you can actually see some of those structural things going on in that galaxy. Because typically when I shot that, it would be just kind of like a white blob and not much in it. But if I just kind of backed it off and not try to get so much a pretty picture, but more a detail so that I can see what's actually going on in here, there's a lot of detail you can see in an image, just like this one, taken from your backyard. So it's something that certainly with a little bit of time that anybody can do. So that was what I want to show.
It's amazing, Paul. Like the detail there, you've got all that blue, those blue clusters. So those are all hot young stars. Some of these might even be forming. I know they're galaxy clusters, but or star clusters, but I don't know. I'm looking for globular clusters, and they're probably some of the whiter dots that are up there. The larger ones are probably the globs, because
Yeah.
we've got over 150 globs that are following that are around us, right around the center of our Milky Way galaxy.
Hmm.
And I guess the total stars here, really, when we're looking at Andromeda, is up to a trillion now. They're saying
Wow.
300 billion in the arms, or in the dust lanes that you're talking about here, but another 700 billion in the center.
That's unbelievable.
Yeah, I mean those numbers are just they're not. But what an excellent way here to be able to study a particular part of the sky, though. It's a great idea you've got here. I mean, really capture it and then go back and look at it and look at the detail that you've captured later on.
Yeah, yeah, it's nice. And you mentioned star clusters, and I'm not sure where it is in here. I was reading about it, but I didn't get enough time to locate it. But there is a huge star cluster in Andromeda, and I'm not quite sure where it is. But some of the viewers may know where that is. But anyway, yeah, it's just a lot of fun.
So I probably wouldn't get that shot with my flip phone, right?
Try.
Long exposure. Oh, Trudy mentioned outreach, Grand Bay tomorrow night. Yeah, so we've got, there's a winter fest, I guess, going on in Grand Bay if you are local here at Brundage Point River Center, uh, beside the Westfield Ferry. So we'll be putting on a presentation there at 6 o'clock. Kurt Nason will be presenting there, giving us a talk about the night sky. And some of us will be there set up with telescopes outside the River Center in the backyard. So you're more than welcome to come out and join the group of us there. It should be a fun day and fun evening at the Winterfest.
Did I hear something about s'mores?
Yeah, it's called Stars and S'mores. So yeah, I think you probably heard that part. You didn't hear the star part, but the s'mores, yeah.
Gotta
Yeah,
have the
there you
candy.
go. Anyway, I'm going to pass that out to everybody who'd like to come join us. Remember too, if you're local, we do set up at Saints Rest Beach a lot. Our next local meeting at the St. John Astronomy Club will be on the first Saturday of the month of March. There is a RASC meeting as well. Our RASC New Brunswick chapter is meeting in Fredericton next week, I believe. So there's lots going on. You can find that information out at sjastronomy.ca. That's our local website, or rascnb.ca is our provincial website. So I guess we've covered a lot of material here tonight. Great, Paul. Thanks for all the talks. Great information. And maybe we'll bring up your shot again next week and take another look at that, because there's a whole lot in there to talk about.
Absolutely, yeah.
Especially the cloudy skies like we're getting.
And we wanted to say hey out there to Mike. He's working tonight.
That's right. Hey,
Make
Mike.
it in, but he's with us. We were chatting a little bit in the side, so we're
Yeah, he's been talking to us all along here. And Mike's final comment, as we try to say, is keep your scopes pointed up. So for that note, we'd like to say good night, folks, and thanks so much for tuning in again. It's been great. We've had a lot of fun here tonight, and we're hoping to keep it fun. So again, if you have any comments that you'd like to talk about on the show, just put it in the comments section afterwards. Also, if you we would like to see us, give us a like if you're enjoying what's coming to you. Also, subscribe if you haven't subscribed yet, and pass this information on to others that they're more than welcome to join us live. We like to keep this live show. Gives us the ability to be able to talk to you folks and get your points out there as well. So we're going to keep this as live as much as possible. So great for everybody for joining. Thanks for joining on again, and we'll see you all again next week at the same time, same channel. Thanks, Paul.
all right. Good night, everybody.
Good night, everybody.